Good morning class, welcome back to the next lesson. I am looking at the document called Frames1 that I posted on Blackboard some weeks ago. It's called Frames1. On the first page it's called Exercise1 and figure 6.33F. If you take a quick look at the document, it looks something like so. Okay, I'm going to look just at this one over here. All I'm going to do for this one, because it's a fairly simple one really, all I'm going to do is find the reactions for this particular frame. Okay, I won't work through finding the sizes and the nature of the forces for the frame. I'll just find the support reactions for this frame. Okay, and then I'll do another frame where I will work at its reactions and find the forces in most of the members of that frame. So here we go. So here's figure 6.33F. First thing you do is you need to show, or you need to put in the reactions where you think it's going to be, whether it's going to be up, down, left or right. And there's a pin joint and there's my roller joint. And from the note before, a pin joint will always have two possible reactions and a roller joint will have one possible reaction. Right, so let's throw that in. Now this is my pin joint. I am going to assume that there's going to be a horizontal force coming out like so. And there's going to be a vertical reaction in there, like so. And now remember, we have a roller joint. It's free to move this way in the vertical plane. So it's going to have a horizontal reaction, and I'm going to say it's going to do something like so. Okay, right, that's point C. I'm going to call this HC, and I'm going to call this VC. I'm going to call this HD. Right, what's the next step in the process? I take moments about the pin joint. Why? So I can eliminate those two reactions and find that one. Okay, so let's do that quickly. Let me just change something over here. Right, I'm going to say the sum of the moments about C is equal to 0. I'm taking moments about the pin joint. Right, so let's imagine this frame wants to rotate about point C. Okay, so we can see about this point here, we got that force acting, that force acting, that force is also acting, but it's acting at this joint here, so it will have no moment effect about point C. And this force here is having a moment effect about point C. Okay, so we've got 1, 2, 3 forces. This force HT, because it's causing a clockwise moment with respect to C, will be positive, and that force will be causing an anti-clockwise moment with respect to C, so it's negative. Doesn't matter the order, just take all of them like I've said before. I'm starting in the positives first way possible, so I'm going to say HD. And what's the definition of a moment? It's force multiplied by distance. In this case, 4 meters. Just 4 minus this one here is 8. What's its lever arm? Its lever arm is 4 meters. Minus 4 times 8. So it's minus 4. And its lever arm is 8. Are there any more? No, there's no more. So it's equal to 0. Okay. So therefore HD, we have one formula. Sorry, we have one equation with one unknown. And therefore we can solve for HD. So pick up a calculator. Let me put that in answer to 2 places after the decimal. So it is 32 plus 32 is equal to divided by 4 is equal to. So it is 16 kilonewtons. Let me just. So I get 16 kilonewtons. And because I get a positive answer, it means that assumption that HD is going to the left is in fact correct. let me just trace something here. That sign there that positive sign there means it's going clockwise. That minus sign means it's going anti-clockwise. That minus sign means it's going anti-clockwise. And that positive sign there means that our assumption that HD is going to the left is correct. And notice there, the plus sign just means our assumption that HD is going to the left is correct. Okay? It doesn't mean that HD is going to the right. A lot of students make that mistake. That plus sign there is not for direction. That plus sign there means that our assumption that the direction of this force which is going to the left is in fact correct. Did you get that? That plus sign there means our assumption is correct. Right. Let's continue with taking moments. Now people, we can take moments about D to find HC, but at this point we're getting a little smarter. Okay, we now are going to sum horizontals to find HC. So I'm going to say the sum of the forces in the horizontal plane is equal to 0. How many horizontal forces do we have acting? We've got HC and HD. Do we know HD? Yes, we just found HD. Let me just put it in here. HD is equal to 16 kilonewtons. So an HD is going to the left, so it's minus 16 plus HCY plus HC, because we assumed it to go to the right, so it's plus HC is equal to 0. Therefore, HC is equal to 16 kilonewtons as well. And because our sign is positive, it means that HC is in fact going to the right as we assumed. So I'm going to say is equal to 16 kilonewtons. Are we done? No, we need to find VC. How do we find VC? We sum vertical forces. So I'm going to say the sum of the forces in the vertical plane is equal to 0. How many verticals do we have acting? We got 1, 2, 3, 4. Can you see that? We got 1, 2, 3, 4. Right. Doesn't matter the order, just all of them. I'm going to say minus 4, minus 8. That will be minus 4 plus VC is equal to 0. Right. Sorry about that. Right, so let's see what VC is. So therefore VC is equal to which is equal to 16 kilonewtons. Oh, they all just happen to be 16. Okay, and because our sign is positive, it means that VC is in fact going upwards. Okay. Alright, now people, what I'm going to do is, as a check, just as a check, I don't have to, I'm going to take moments at this point here to determine HD. Okay, so with that we see that that HD and that one there checks out. So let me just give me a second here. Right, let's see. So I'm going to take moments about D to find HC. Okay, so I'm going to say the sum of the moments about D is equal to 0. Alright, I'm taking moments about D. Alright, so about D, I've got HC as a positive moment, okay, but we just want to turn clockwise with respect to that point. So it's HC times 4, okay. That force goes to the point of rotation, so they have no moment effect, but that one and that one will be negative with respect to D. So it will be minus 8 times 4 minus 4 times 8 minus 4 times 8. There's no more. It's equal to 0. Therefore, HC is equal to 32 plus 32 over 4. Did I do that correctly? I've worked it out. Yes, it is, and it is equal to 16 kilonewtons. And because the answer is positive, it means that HC acting to the right is in fact correct. Okay, so that answer and that answer there checks out beautifully with each other. Okay, so to recap, I took moments about the pin joint to find HT, and then I summed horizontals to find HC, and then I summed verticals to find VC. After this point here, I could have taken moments about D to find HC. So I can either do this, or, notice the word or I can either do that there. Okay, but from here on in, this will be the normal procedure. Okay, so once we found HC, VC, let me just say VC is equal to 16 kilonewtons. I can now go ahead, visit joint to joint, use a method of joints, and find the nature of the forces in all the members. So, which joint can I go to? I can either go there, because I've got two unknowns, or I can go there, and I've got one unknown, or I can go there to find that member and that member. Okay, I can't go there, because there's three unknowns. I can't go there, because there's 1, 2, 3, 4 unknown. So I can either go there and work to the left, or I can start there and go to the right. Okay, I'll leave it up to you. The answers are in the hand that I gave you. Let me just have a quick look at it. Where's my frame? There's my frame. So that's figure 6.3, the F, exercise 1. Okay, so if I go down exercise 1. Exercise 1, figure 6.3F, and all the answers will be over there. Okay, thank you for that, and I'll see you in the next lesson.